let's say that you activated guard duty, and now there are some findings popping up in guard duty. What are now the remediation steps for the different scenarios? This is explained in the documentation, and I'm going to go over all these remediation steps, starting with EC2 in this lecture. So we're going to have EC2, S3, ECS, AWS credentials, and then containers. Containers, databases, and Lambda functions. Guard duty, when it, for example, finds a compromised Amazon EC2 instance, it's not going to do anything with it. It's just going to give you the finding. It's your job to then either implement something automated or a manual remediation. And AWS has described here in the documentation how to remediate certain scenarios. So let's start with EC2. Let's say we have a finding, there's malware found on EC2. What do we do? First, identify the potentially compromised Amazon EC2 instance. So in guard duty, that should be pretty obvious. It will show you the instance ID. In cases where it doesn't show you the instance ID when you have a finding in guard duty or other systems, what is very helpful is the network interfaces right here. Because here you can find the IP address attached to a network interface. An EC2 instance has those network interfaces attached. So if you want to find an IP address, it can even be an IP address of a load balancer or of a NAT gateway. You will be able to filter right here on a private IP address. So for example, if I want to know what is attached to 10.05.81, I will see this ENI ID is attached to it. I can do the same with public IP addresses. So if I have a public IP address 54.74.91.182 that I see somewhere listed, then I can find also the network interface ID based on that. So once we know the network interface ID, we can then figure out what instance it is attached to by either finding here the instance details or looking up the network interface ID when we are filtering for instances on our instance page. Right here, we don't have any information in our instance details because this is an ELB, which is a load balancer. So once we have identified the EC2, then we should isolate the potentially compromised Amazon EC2 instance. And how do we isolate it? We need to first create a dedicated isolation security group. And that security group should have no inbound or outbound rule that allows traffic. And that can be a little bit tricky because if you have created a security group earlier, then almost always it will have this outgoing outbound rule for all traffic by default. Because every time you create a security group, it has outbound all traffic to all IP addresses pre-configured. So what you need to do is, this is my isolated security group for compromised instances. What I need to do is I need to make sure that we don't have any inbound and any outbound rules. Create a security group and then use this security group for our EC2 instance. So we would remove all security groups on our EC2 instance and only keep this one so that we don't have any inbound or any outbound rules. Alternatively, you can also just remove all inbound and outbound rules of an existing security group that is already attached, but then later on, when you want to revert back the old security group's rules, you need to have it written down somewhere so it's easier to swap them out if you don't have your configuration documented. There's one important note here. The existing tracked connections won't be terminated as a result of changing security groups. Only future traffic will be effectively blocked by the new security group. So what happens is that security groups are stateful, which means that if a connection is made, then the connection is made and will always be passed through. So now that there are no rules, no new connections will be allowed. But connections that already have been established, TCP connections that already have established, they will still be allowed. So one way of resolving that is to use network ACLs. In the VPC, we have network ACLs. So depending on what subnet your EC2 uses, you can go to the network ACL for a specific subnet. And the network ACLs are not stateful, they are stateless. So if you then create a rule to deny traffic, then existing traffic will also stop working. So that's something that you really need to think about, that, okay, when you change a security group, the traffic that already exists, that already made a connection, will still be allowed. So either you use the network ACLs or you log into the instance using SSH. You can, for example, allow SSH to your IP address, have a look at the traffic that already have made connections, and try to figure out whether that is malicious traffic, for example, traffic that goes to IP addresses that you don't know about. And if yes, then you can block the traffic on the EC2 instance. You can either stop certain services. For example, if traffic is from a web server, you can stop the web server, or you can use a local firewall to terminate these connections. The typical tools that I use for that is Netstat and a tool that is spelled LSOF. So the LSOF command is an acronym for list open files. And open files can also be network connections. So open files and Netstat is what I use for network debugging on the instance. Once you have isolated the instance, you need to identify the source of suspicious activity. So that means that you need to identify and stop the potential unauthorized activity on your EC2 instance. If it's through a service that was not updated, for example, then it's quite obvious. For example, you have Jenkins running on it. That Jenkins version is very out of date. You see that this is the way that malware came into the EC2. You can remediate that by upgrading, checking the instance if there's no more malware on it, and that would be a resolution. And this is just one example. But if you cannot identify and stop the unauthorized activity, then AWS recommends to terminate the compromised EC2 instance and replace it with a new instance. So for example, again, the Jenkins example, if you're not 100% sure that just upgrading it to the latest version will stop the unauthorized activity, then you could, for example, set up a new EC2 instance, copy the configuration files over, and start working from that new instance, terminate the old instance. That's the safest way of recovering from a compromised EC2 instance. They have some other options here. There's also the AWS repost, so there's some kind of forum where you can have a look at, or you can even submit a technical support request to ask for AWS's help, which is only if you are a subscriber to their support plan. So of these steps, the identifying the compromised EC2 and the isolating of the EC2 is very important to do it very quickly. Once it is isolated, it can still take some time before you can identify the real source of the breach, and then it can even take longer to then come up with a plan to completely remediate it.